Hello there. Assalamualaikum and salam sejahtera. In today's lesson video, I'll be sharing on how to use the Gaussian elimination to solve a system of linear equations. Let's look at the system of linear equations with three variables. In example 1, we have three linear equations where the three variables are x, y, and z, and the coefficients of the variables are real numbers. In example 2, a system can also be in this form, where the variable y does not appear in the second equation and the variable x does not appear in the third equation. We will apply the Gaussian elimination to find the values of the three variables. So what is a Gaussian elimination? It is a process that involves elementary row operations to reduce a matrix into row echelon form. Note that when a matrix being in row echelon form, it means that the Gaussian elimination has operated on the rows. You can look up in my previous lesson video to recall what is a row echelon form matrix. Okay, let's together solve the system of linear equations given in the example. When using Gaussian elimination, the first thing that we need to do is to write the augmented matrix of the system. That is, by writing the coefficients of the equations on the left-hand side and the constants of the equations on the right-hand side, separated by a vertical line. Then, we will use the elementary row operations to reduce it in row echelon form. To reduce the augmented matrix into row echelon form, we first divide row 1 by 4, so that the top left-hand corner is 1. Next, we need to obtain zeros below the leading entry 1. This can be done by multiplying row 1 by 3 and subtract row 2 from the product to produce a new row 2. And for the third row, multiply row 1 by 2 and add the product to row 3 to produce a new row 3. And we have. Then we interchange row 2 and row 3. Row 2 is divided by 5 and row 3 is divided by 8 to produce the row echelon form matrix. We can stop the Gaussian elimination process since we now have an equivalent matrix in row echelon form. The corresponding system of equation to the row echelon form matrix is we use back substitution to solve the system. So we back substitute the value of z equals -2 into the second equation to solve for the value of y. Then we back substitute z equal -2 and y equal 1 into the first equation to solve for the value of x. Thus, the solution to the system is -3, 1, -2. Now let's try another example. The first step is to write the augmented matrix for the system. That is, the left-hand side of the augmented matrix are the coefficients of the equations, and the right-hand side are the constants of the equations. Notice that a missing variable in the first equation corresponds to a zero entry in the augmented matrix. Now we need to reduce it into row echelon form. Notice that the top left hand is already 1. Thus, all we need to do is to obtain zeros under the leading entry 1. So the elementary operation to be carried out are, for row 2 is to multiply negative 3 to row 1, and the product is added to row 2 to have the new row 2. And for row 3, negative 3 is multiplied to row 1, and the product is added to row 3 to produce the new row 3. And we have. Then to obtain 0 below the leading entry 1 in the second row, we multiply row 2 by negative 2, and the product is added to row 3 to produce a new row 3. This will produce a matrix in row echelon form, so we can stop the Gaussian elimination process. The corresponding system of equation to the row echelon form matrix is. Then, the back substitution is used to solve the system. We back substitute z equal 3 into the second equation to solve for y, and we back substitute z equal 3 into the first equation to solve for x. Thus, the solution to the system is 2, negative 1, and 3. As a conclusion, when solving using Gaussian elimination, the 3 important steps to be taken are: write the augmented matrix of the system, use elementary row operations to reduce the augmented matrix into row echelon form, write the new system of equations that corresponds to the row echelon form of the augmented matrix, and solve by back substitution. That's about all for today. Hope all of you have understood the lesson. Till then, don't forget to subscribe, like, comment, share, and watch out for the next video at Cikgu Zana's channel. Bye!